Hello students, this is your professor Dr. Sharma. This is the first asynchronous class for this semester for Physics 205. So in Physics 205, the first in-person class will begin on August 20, Friday 2021 in Smith Science Room 117. I will see you all in the in-person class during that time on August 20, Friday 2021. But today we are going to discuss about some basic concepts that are necessary to succeed in Physics 205. So basically in today's asynchronous class we'll be talking about the measurements and unit, and then we will be talking about some significant figures and scientific notation, because these are the basic things you need to understand in order to succeed in this Physics 205. Let's talk about the measurement. When you talk about the measurement, every time you always take the measurement of something. For example, if you measure your weight, if you measure your height, if you read your watch, if you take your temperature, so all of these things are associated with the measurements. So measurement is very important things when it comes to the science. As a student in life sciences, you might ask a question: how much does a cell weigh? So if somebody asks these questions, you'll take the measurement. Answer will be, it is 27 times 10 to the power minus 15 kilogram. So 27 times 10 to the power minus 15 kilogram. If somebody says this, what does it mean? 27 times 10 to the power minus 15, that means tiny size or magnitude, and kilogram is the unit. So when we talk about the measurement, there are two things associated with this. One is size or magnitude, and another is the unit. You know that the red blood cells are replaced every 120 days. What do you mean by 120 days? 120 is the size or magnitude, and the days is the unit. So if we talk about the measurement, there are the size or magnitude and the unit. So 120 days. 120 is the size or magnitude of their measurement, and the days is the unit. So every measurement has size or magnitude and their unit. So every day in our lives involves measurements. Understanding them and communicating them to others. In other words, we all have to speak the same basic language. Whether you are a chemist, a physicist, a biologist, or even a medical doctor, you need a consistent way of communicating size, mass, shape, temperature, time, amount, power, speed, and so many other physical quantities of interest. So every measurement, a number is followed by a unit. So let's observe the following examples of measurements. So here you have the number and the unit. So if someone says that 35 meter, what does it mean? The 35 is the number and meter is the unit. So 35 is the size or magnitude. 35 meter, what it represents? It represents the length, right? It represents the length. Someone says that 0.25 liter. So it represents the volume of the substance, right? 225 lb. So it represents the weight. So 3.4 hour, it represents the time. So here you can see here the size or the magnitude of the measurement, and you express this measurement in the consistent way of unit, right? And then you have the physical quantities of interest. So these are physical quantities. So every physical quantities, they can be measured, are the physical quantities. And these physical quantities lies length, volume, weight, time, and so on, should be measured using a number followed by a unit. So let's talk about the metric system and SI system. So if you look at the history of metric system and SI system, so after the French Revolution, metric system was introduced. After 1960, the international system of units, which we call the SI system, which was adopted at that time, and this SI system is it has the only official status in nearly every country in the world. So it comprises basically 7 base units, coherent system of units. So basically it is based on the
decimal system 10 because it is easy to convert. For example, if I talk about 100 centimeter, the length of the stick is 100 centimeter. So if I want to convert it into the meter, it would be 1 meter, right? So it is based on the decimal, based on the tenth. Okay, so 1 meter. So for example, 1 centimeter, if I convert 1 centimeter into meter, it would be 0.01 meter. So it all based on the 10. So I already told you that it is used, SI system is used most of the world, and it is used by everywhere by the scientist. So I already told you that it comprises a coherent system of unit of measurements starting with 7 base units. So these 7 base units are length. So length is measured in meter. Mass is measured in the kilogram. Time is measured in the second. Temperature is measured in Kelvin. Amount of substance is measured in mole. Luminous intensity is measured in candela, and electric current is measured in ampere. So volume is not base, okay? It is not base quantity. It is the derived quantity. I'm not going to discuss much more about the physical quantities because in physics 205, at least you need to have some concept about the unit conversion. That's why I'm making the background.
Let's take a time to check your learning or understanding. You have 4 problems here. Pause this video and check your understanding here.
And you have, for each of the following, indicate whether the unit describes length, mass, or volume. You can pause the video and then think about that. In number A, you have a bag of tomatoes is 4.6 kilogram. Number B, a person is 2 meter tall. Number C, a medication contains 0.50 gram aspirin. Number D, a bottle contains 1.5 liter of water. So, definitely, number A indicates the mass, right? The physical quantity is mass, and its measurement, you take the measurement, it is 4.6 kilogram. 4.6 is size and magnitude of your measurement, kilogram is the unit, SI unit. So a person is 2 meter tall. What does it mean? It means height. Height. What does it mean? In physics we use that is length, right? Length measurement. Number C, a medication contains 0.5 gram aspirin. It represents again mass, right? Mass. So a bottle contains 1.5 liter of water. 1.5 liter of water. So it represents the volume. So you have to familiar with the physical quantities. So physical quantities and their measurements. So mass, length, volume, temperature are the physical quantities.
Now let's talk a little bit about the unit conversion. Unit conversion is very important to solve the problem in physics 205. So let's begin with the very simple example. Convert 365 days into seconds. So you have to convert days into seconds. So you have to convert days into hour, then hour into minute, and then finally the second. So to convert days into seconds, so you need to know about the conversion factor. So you know that 1 day is equal to 24 hours, then 1 hour is equal to 60 minutes, 1 minute is equal to 60 seconds. So you know these conversion factors. So let's begin how to convert 365 days into seconds. Look at here. First you have to write how many days you need to convert, 365 days. Then you have to convert into hour. To convert into hour, you have use this conversion factor, 24 hour divided by 1 day.
because that is equal to 1. You see here, 1 day is equal to 24 hour. Let me use different color. So that means this can be written as 24 hour over 1 day, which is equal to 1, right. So this term is equal to 1. So 24 hour divided by 1 day, that convert day into hour, and then hour into minutes. So conversion factor hour to minute is this, 60 minute is equal to 1 hour. So that can be written as 60 minute divided by 1 hour, which is equal to 1. So this is the conversion factor you use here to convert from hour to minute. And then minute, finally minute to second. So you know the 60 second is equal to 1 minute. So this can be written as 60 second divided by 1 minute, because this is equal to 1, this is equal to 1, this is equal to 1. So if you multiply 365 day by 1, all gives 365 day, but we are dealing with the unit. So this day and this day cancel, this hour cancel, this minute cancel, only second left here. So then if you multiply 365 by 24, 365 multiply by 24, multiply with 60, multiply with 60, it gives 315360000 second. So that's how you need to convert units. Let's take another example. Okay, so this is a basic example. Now somebody says, how many meters per second would you be traveling if driving a car at 50 miles per hour? This is the speed of the car. We will be discussing about speed. Okay, speed of a car, which is 50 miles per hour. You have to convert into meter per second, because in SI system unit of the length is meter, unit of the time is second. So meter per second, you need to find that one. So how to do that? So first mile is converted into kilometer, then you have to convert into meter. What is the conversion factor? Here 1 mile is equal to the 1.6093 kilometer. I will give this data, okay, you do not need to memorize. 1 mile is equal to 1.6093 kilometer, and 1 kilometer is 1000 meter. And time, regarding time, we just converted the time conversion factors previously. Then 50 mile per hour, this is the 50 mile per hour. Okay, we need to convert this into meter per second. So first we need to convert the mile into kilometer. Okay, let's convert 50 mile into kilometer. So what we use, which factor? This. So just use this, 1.6093 kilometer divided by 1 mile. Okay, here is the one thing I want to emphasize here. You know, 1 mile is equal to 1.6093 kilometer. So I can write it 1 mile divided by 1.6093 kilometer is equal to 1, or 1.6093 kilometer over 1 mile equal to 1. Same thing, right? But why
to change from mile into kilometer, I use this conversion factor. I use this where on bottom the mile is there, on top kilometer is there. That is why I use this factor, okay? Because this mile will be cancel out, then it gives the kilometer. Now you converted mile into kilometer, now convert the kilometer into meter. So you have to use this conversion factor, 1000 meter divided by 1 kilometer. Why I put 1 kilometer on bottom and meter on top? Because this kilometer will cancel and only meter left. So we converted 50 mile into meter, but we have per hour. So we need to convert that per hour into per second, okay, per second. So to convert per hour, this is in the denominator. To cancel that hour must be on top and minute must be in the on the bottom. So in conversion factor, you know that 1 hour is 60 minutes. So 1 hour divided by 60 minutes is equal to 1. So this term is equal to 1. We can multiply anything with 1, that gives the same thing, anything, right? So I use this conversion factor to convert hour into minute, and then you convert it per minute. Now you have to convert it into per second. So you use 1 minute divided by 60 seconds, so that this minute cancel, only this hour and this hour cancel, right? So only things left is 50 1.6093 multiply with 1000, and meter is here also, and on the bottom you have 60, you have 1 and 1. If you multiply with 1, it gives 1, so it does not matter. So second is also here. So if you do that, it gives you 22.3514 meter per second. So it means if you driving your car 50 mile per hour, it means you are driving with 22.3514 meter second. So that is how you need to convert the one system of units to another system of units, basically in SI system of units, or we can convert one system to another system if you know the conversion factors. So this is very important concept. Please go on your textbook and you can try a little bit more. So here I just want to give idea how to do this.
Let's conclude the discussion about measurement and unit. In next video, I will be discussing about the scientific notation and the significant figures.